Hello, statisticians. Today's lesson is on privacy and experiments involving human participants. Let's get started. Parents have worried that their kids spend too much time using a certain piece of technology that gives them access to addictive media content. Can you guess which technology? That's right. It's the radio. Yes, that's right, the radio. In fact, in this 1934 article from the New York Times, they observed that the radio seemed to find parents more helpless than did the funnies, the automobile, and the movies. And they included a quote from Sidney Grunberg, the director of the Child Study Association of America, who said, quote, "It's beyond dispute that many programs are objectionable because they convey false ideals or misleading sentimentalities, or because they murder the King's English or play too recklessly with children's fears and horrors." A travesty indeed. But of course, it turns out that kids who grew up listening to the radio ended up becoming well-adjusted adults. However, that trajectory didn't stop those new adults from worrying about their children's access to another new invention, the television. In a letter to the editor published in the New York Times, this time from 1950, a concerned reader reported that grades were dropping among students who had TVs at home. They went on to say that, quote, "The statistics in themselves make it abundantly clear that television represents a new problem for the world of education, extending far beyond the classroom itself. Such a medium that can command such a high portion of a child's waking hours is not a mere novel form of entertainment. It is a social force." And of course, it didn't stop here. The children who grew up on television then became adults who worried about their own children's exposure to arcades and video games. In 1982, you would have found in the New York Times this letter to the editor where the author worried that video games were, quote, "cultivating a generation of mindless, ill-tempered adolescents." And finally today, the children who grew up on video games have become adults now, worried about their children's use of social media. And you don't have to look too far to find expressions of their worries. A quick Google search yields many results of articles voicing concerns about teenagers and smartphones, and particularly about the impact of social media on mental health. But unlike prior tech hysteria waves, this one is associated with some real and potentially concerning data. 2008 was a pivotal year for social media. The iPhone store and an earlier version of the Google Play Store called Android Market both launched. And that meant that constant access to social media through smartphones started becoming more widespread in the years that followed. So 2008 can be considered one of the last years before the social media boom. And we can look at different youth mental health metrics between that year and more recently. Specifically, if we look at the percent of US individuals aged 12 to 17 who had major depressive episodes that year, we can see that just before the social media boom in 2008, the rate was 8.2%. By 2024, it was 15.4%. That's nearly doubled. In 2008, 10.4% of US university students had an anxiety disorder. In 2019, that rate was 24.3%. That's more than double. In 2008, 217.2 out of 100,000 people in the 12 to 18 age group had visited an emergency department for self-harm. In 2023, that rate was 518.5 per 100,000. That's a lot more than double. Now, phones and social media are one thing that could explain these trends. However, since 2008, US teens have faced a global financial crisis in the Great Recession, a pandemic from COVID-19, threats of climate catastrophe, and so much more. How do we know if social media is truly a cause of decline in mental health rather than other potential factors? And trying to figure out that is our key question for today. Specifically, has social media caused declines in mental health? With that question in mind, we move into our notes. We are going to cover 3 topics today, starting with placebos and blinding. Now, before we fully tackle the key question, we have to deepen our understanding of the type of study that can answer causal questions, experiments. In particular, we need to explore the additional considerations involved in experiments that utilize human subjects. To start, let's first consider the idea of a control group. A control group is a comparison group that is not given the treatment of interest. To see a control group in action, let's think about designing a study to answer the question, do scarecrows actually keep birds away from crops? Well, in this case, we'd have a bunch of fields growing crops, and about half of those fields will be randomly assigned to receive a scarecrow, and the rest get nothing. So here's what the groups would look like. And the control group would be fields that get nothing. Now, unlike birds, when the experimental units are human beings, rather than giving no treatment, control groups often get inactive treatments. Here's why. Imagine you give your younger cousin a glass of water. You tell them a small lie, that the water contains a new kind of invisible, tasteless sugar, and they drink it. And 20 minutes later, they might be acting like this. This is called the placebo effect. It happens when, even though a human participant gets an inactive treatment, called a placebo, the belief of receiving treatment leads to a measured response. A placebo effect is quite common in contexts in which human beings are the study participants. Since humans have expectations when getting a treatment, these expectations can lead to real effects. For example, placebo pills with no active ingredients have been shown to produce real beneficial effects for migraines, blood pressure, asthma, arthritis, and many other illnesses. This shows the strong connection between the brain and the rest of our body, where sometimes believing in a treatment, even if it's not there, can yield true physical effects. To control for the placebo effect, giving the placebo like a sugar pill or a saltwater IV drip, this makes sure that both groups believe they are receiving the treatment. Studies with placebos fall into 2 categories. In a single blind study, either the subjects or the researchers who interact with them are unaware of who receives the active treatment or the placebo. In a double-blind study, both the subjects and the researchers who interact with them are unaware of who receives the active treatment or the placebo. These setups can also be called single-masked or double-masked studies. So, why would you choose to blind the subjects? Well, blinding the subjects controls the placebo effect, since everybody thinks they are potentially getting the treatment. But why blind the researchers? Well, blinding the researchers prevents direct confounding from researcher bias. For example, researchers trying to prove that a treatment works may favor the treatment group in their measurements, thereby unconsciously affecting the results. If they don't know who is in the treatment group and who is in the control group, they'll look at all participants the same way. So, now let's return to our key question. Has social media caused declines in mental health? To answer this causal question, we need to do an experiment. In particular, an experiment involving human beings. So that brings us to our next topic, generalizability of experiments. So it turns out that there is a quickly growing body of research related to how young people's scrolling habits are impacting their well-being. Today we're going to look at this study conducted at Iowa State University titled "The Effect of Self-Monitoring Limited Social Media Use on Psychological Well-Being." Researchers at Iowa State University recruited 230 student volunteers for their social media experiment. They looked at two possible treatments of how students engaged with social media. One was to use social media as they normally did. The other was to limit social media use to 30 minutes per day. They randomly assigned their participants to the two groups, then waited 2 weeks to see what would happen. In psychological evaluations, the time-limited group demonstrated significantly lower anxiety, depression, loneliness, fear of missing out, and negative mood. Notice that these results are listed as statistically lower. Statistically means that differences were so large that they were unlikely to happen just by chance. We'll talk about how to determine statistical significance later in this course. But a main takeaway here is that this effect was causal. Because the subjects were randomly assigned to treatments, we can say that the limited time on social media caused the improvements on these indicators of mental health. So the relationship between social media and mental health appears, at least in part, to have some causal component. Now, one aspect of these results that we should consider a bit further is that these students in the 30-minute per day group were expected to self-monitor their social media use. And at the end of the experiment, they shared their phone data with researchers, but researchers never enforced the 30-minute time limit. Remarkably, even though researchers did not enforce the restriction, there was still a significant treatment effect. It makes sense to wonder then, can this result truly be generalized to all students at the school? Remember that the 230 students in this experiment were volunteers. Therefore, a potential problem is in voluntary response bias. That is, compared to others, students that are willing to proactively volunteer to participate in a social media reduction study may be better at limiting their own social media use than others in the population who might not show interest in volunteering for such a study. In other words, these students might be different in their willingness to stick to treatment than other students at the school. So, when looking at the scope of conclusions for this study, we need to consider not just how the study was designed, but also how they recruited participants. Since the experiment was randomly assigned, we can see a causal relationship. We know that among the students in the study, there was a causal effect from limiting social media. However, because the sample was volunteer-based rather than random, we can't generalize this result to the whole student population. We can only say that the treatment would likely create an effect among students similar to those studied. In particular, for students not similar to those studied, maybe those that are more attached to their social media accounts, who would be less willing to stick with guidance, this treatment might not be as effective. This raises the question, to make their study more generalizable, why didn't Iowa State researchers gather a random sample of all students on campus? Well, because it would be unethical and infeasible to force randomly chosen students to participate in the study. You can't force someone to sit for psychological evaluations, check in with researchers, share their phone data, and so on. For a study like this, you have to work with volunteers who give their consent to participate. This brings us to the final topic of the day, personal data privacy. So researchers at Iowa State University found some pretty compelling results from their study and gathered some rather detailed data on the participants. This raises the question, Beyond publishing their general findings, what can researchers do with the data they collected? Let's begin by imagining you were one of the 230 volunteers. Would you be okay with people knowing that you were participating in a study that might make you limit your social media for 2 weeks? You might be fine with that. In fact, you might even tell people that you were doing it because they might wonder why you hadn't clicked on all the funny videos that they had shared with you. But let's think about the study a bit more. They considered 6 dimensions of psychological well-being, including anxiety, depression, fear of missing out, loneliness, positive effect, and negative effect. Would you be okay with your friends and the public knowing how your psychological evaluation went, both before and after? These are the types of concerns you have to be aware of when conducting an experiment with human participants. In particular, researchers need to be careful when handling data that includes personally identifiable information, or PII. PII is data that can be used to identify a specific individual. It can be directly identifiable information, meaning that one single piece of information will let someone identify you. Your full name, including any middle name or extra add-ons like Junior, is likely to make you identifiable. Your social security number is unique. You are the only person with that number, so if someone has it, they can pick you out of any group. Indirect PII is not quite as strong an identifier, but if someone has 2 or more of these, they are likely to be able to identify you. Think about the hospital where you were born, your birthday, a church or other organization you belong to. Perhaps if someone has many of these pieces of information, and even sensitive information like your medical information or passwords, these can cause significant troubles if someone with bad intentions puts it all together. In our study of statistics, we want to focus on PII as it relates to gathering information for research purposes. The National Institute of Health, or NIH, has identified principles and best practices for protecting participant privacy, which basically say that no matter how you are collecting data about people, you have to consider their privacy. And even if the data collection was done by someone else, how you share it must abide by those principles and practices. All research institutes have similar statements, and when considering an experiment involving human participants, privacy must be part of its design. So let's turn to our discussion for today. Every day we have opportunities to subscribe to groups, download apps, make medical decisions, or complete financial transactions. Many of these require information about you and some sort of permission. So our discussion question is, what will you think about the next time you are asked to click accept or sign your name for permissions? So take a moment to jot down your initial thoughts on this question, and we'll discuss further in class. That's it for today, statisticians. We'll see you next time.